Salutations, my children, and welcome back to another guide that I am here to bestow upon you. This time, we're going to be talking about performance task number 2, lessons 3 and 4 in math, graph my masterpiece. So, as it says here, draw a masterpiece or an artwork which involves the graph of polynomial function in a bond paper, any size, or you can do this in digital as well. Then on a separate paper, describe the graph and note the important details. Show your solution. So from this point, you draw a masterpiece or an artwork which has something like this or these drawings that involves the graph of a polynomial function. And then you describe this graph, and then you note the important details as shown in here. So we're going to make use of this table, but first I'm going to explain to you the concept of this. Alright, so what the project invites us to do is to create a masterpiece, an artwork like this. For example, you create an artwork that has a graph in it, and so on and so forth. Then we describe the graph in a Cartesian plane, and then we put the different polynomial functions like this and that, right? But in this guide, we're going to be doing the opposite. Just to make your lives much easier, it's technically this. We first make a polynomial function, right? Get the factors, make a polynomial function as what I just made a while ago. Make a polynomial function, describe the zeros or the x-intercepts and the y-intercepts. Then we make the artwork. So it's an opposite routine, you could say. Instead of doing the artwork first, we're going to do the function, then draw the artwork. Alright? Together with the graph. Alright, so we're going to start with this. We're going to start with the polynomial function. So as shown in our Let's Apply This, with Eileen's architectural graph right here, what she did first is to create an artwork, then traced it with his graph, then he described everything with functions, factors, and all in the table. But we're going to do the inverted way. So my way of doing this is we create factors first. But first, we're going to be discussing how the behavior of the graph works. So as you can see here in the polynomial functions, we have these, right? These four lined up here in the column. So a degree is where we'll know if the leading coefficient with its exponent is either even or odd. In order to find the degree, we have to look at the leading coefficient here with its exponent. In this one, we have 2x squared. And as you can see, we got squared, which is even. That's how we'll know we have a degree of even. Next is over here, we got x raised to 4. We got 4, which is also an even number. That's why our degree here is even. But on this other row, we have a degree from the exponent of 3. Right there. So its degree is odd. And then we got 3 again, which is also odd. The next one is the leading coefficient. We're going to find out if it's either positive or negative. Based on our leading coefficient, which is 2, we have a positive leading coefficient. Next is we have a negative leading coefficient because we got negative x. Same thing over again, x that's positive and this is negative. So you may ask, why would we need to learn that? Because that's how the graph would be formed. The behavior of the graph would be formed. So if you have a degree of an even exponent, and a leading coefficient which has a positive sign, the behavior of the graph would be upward, which means this. So if you have even and positive, even degree, even exponent, and a leading coefficient of positive, you have upward. The behavior or how the graph would look would have upward on both ends. It's going to be upward on both ends. That's the final outcome. If you have a negative leading coefficient but it still has an even degree, it's going to go both downwards this time. Both endpoints go downwards on an even negative. Both endpoints go upward on a even positive. For the odd this time, if it's an odd degree with exponent and a positive leading coefficient, it's going to go left downward, right upward. So the endpoints are going to be like this. The left goes downward, right goes upward. If we have an odd negative, it's going to inverse. But this time we have left going upward and right going downward. So now you know the behavior of the different graphs. We're going back to this. Alright, so now that you know that, we're going to now make our polynomial equation. So we start with creating our factors. This is the easy way of doing it, so I advise you to please study if you want to learn more, but this is just my way of putting up and of course making you guys not struggle that much with the performance task. It's much easier. So if you want something that has a degree of 2, you can make 2 factors. I'll give you an example. X plus 2 and then x minus 4, for example. If you want a degree of 2, you do this. But if you want a degree of 3, you're going to have to create 3 factors. Factors are the example of the like you know, inside a parenthesis, which has x plus or minus, and then what value you desire. And that's a starting point, just to make this easier. So I'm gonna give you an example right here. X plus 3, x minus 4, and x minus 2. So if you want a degree of 3, you know, one with the exponent, you go with 3 factors. If you want a degree of 2, of course you go with 2 factors. We're going to do the 2 factors first, but take note of this later on. X plus 2, x minus 4. Right. X plus 2, x minus 4. Alright. So from this point onwards, we're going to convert these into a polynomial function. Remember, we're going to use this table right here. So have that prepared for the next step. So right here, we have our table. We're going to turn these factors, alright, we're going to list of the factor over here in the table. So the factors are x plus 2 and x minus 4. Alright, we have our factor. We're going to find the polynomial function. Alright, so I'm going to explain to you again. A function is something, it's like an equation but has this in the end. And then of course you got your normal things up here and so on and so forth. This is what a function is. So in order to get our polynomial function, we're going to make use of this right here, of our factors. So we're going to put that x plus 2 and then x minus 4. In order to find our function based on whatever value you chose in those factors, because you can choose whatever you want, we're going to use the FOIL method. Simply, it's distribution. So you pair up x with x and negative 4, and then next number, positive 2 with x, then 2 with negative 4, right there. Alright, so knowing that, we're going to write this now. So FOIL it. So x times x becomes x squared. You might ask, how does it become x squared? Because these have an exponent of 1. So if you're multiplying coefficients, the exponents would add, so that becomes x squared. Next is x times negative 4. That becomes negative 4x. Next is 2. 2 times x becomes positive 2x. That adds, and then 2 positive 2 times negative 4 equals to negative 8. Alright. So now, after this point, we're going to simplify this by, of course, adding all of the different like terms that we have. So examples of these is the negative 4x and the positive 2x. So we're going to add both of these together. So now we got f of x is equals to x squared, or x raised to 2. We're adding these, guys, so it creates negative 2x. So remember, yeah, if you're adding these things together, as I've said before, they add with the exponents. This time we're just adding the coefficients, so of course the exponents would still retain and would still be the same. It's negative 2x, then minus 8. And pretty much, yeah, that's the whole polynomial equation right there. So now that we got this, we're going to go to our table and we're going to put in our polynomial function. So f of x equates to x raised to 2 minus 2x minus 8. So because we have this now, we're going to solve for everything in the table. So as I've said before, with the behaviors of the different stuff, we're going to know for exactly what the degree is. So based on the coefficient, we have an exponent of 2 which has a degree of 2, which is of course even. Next is the sign of the leading coefficient, which is, from the leading coefficient, what sign or this is. So that's positive. Since there's no negative, that's a positive sign. Now we're going to find out of our zeros, or our x-intercepts and our y-intercepts along the way. So take note, by the way, when we say about x-intercepts, we're talking about the points inside of the Cartesian plane where our graph is going to intersect inside of the x-axis, while our y-intercept, on the other hand, are going to be the points we'll be going with our graphs inside the y-axis. So take note of that. So in order to find our zeros, or our x-intercepts, what we're going to have to do is to make use of our factors. Doing so, we're going to type it in, or we draw it in, x plus 2 and then x minus 4. So in order to convert these into zeros, we're going to have to set them equal to 0. You know, yeah, it makes sense. So in order to get rid of this, we're going to have to do minus 2, and this plus 4, plus 4. So now x is equals to negative 2 and x is equals to positive 4. That is our 0. So x is equals to negative 2, x equals to positive 4. So now, finding the y-intercept, I mean, as it says here, based on the instruction, in order to find the y-intercept, we just have to look at the constant term of our polynomial function. It is shown here that our constant is -8. So that also means that our y is also -8. So next, last one, the last column, is going to be about the number of turning points of the graph, which, as explained in the instruction here, so I'm going to explain this as well. This is the Cartesian plane, right? Example, alright, so based on this graph right here, the turning points are the points where we turn our graph in order to go into another direction. So those are the turning points, as explained there. Number of turning points can be found by using your degree, which in our case is 2 minus 1. It's always -1. So our number of turning points is going to be 1. We're going to be turning one time, only one time. Alright, now that we have that, our table is complete. So now we're going to go and graph this all together. Alright, so our zeros, our x-intercepts or our zeros is -2 and then +4. Remember, these are x-intercepts, which means these are points inside of the x-axis, while our y-intercepts is -8, which means it's in the y-axis. So now we're going to graph all of these points together. So remember from last time, considering our degree is both even and positive based on this diagram right here, since it's even and positive, the behavior of the graph is going to be both ends going upward. What do I mean by that? Which means from left to right, it will be going upwards. Alright, so now we're going to be graphing that in. From this point, you go here, towards this, and towards here. Alright, so now that we got this, this is the whole graph. Which means, once you get the graph, it's time for you to do your masterpiece. So, now, you'll be converting this into a drawing or whatever you would like. Now that you got this graph, physics education right here, using that graph, it's time for you to do whatever artwork you wish. You know, you can make a cliff, a sunset, hanging off the top. You know, you can do whatever you want. Once you get the graph, do the masterpiece, and then that's everything that you'd have to do. We're going to make an example. Remember the factors that we have for the third degree. Remember, our third degree has x minus 3, x plus 4, and x plus 2. So last time we did a degree of 2. This time we're going to create a degree of 3. So using these factors, we're now going to create a polynomial function. Now we're making a new table because this is going to be entirely new. Alright? So, put and insert here our factors. So it's all going to be the same, by the way. We're going to use FOIL method, which is distribution. But this time it's going to be much more longer. So x, first we're going to do these two terms right here. There's two factors. So x to x, x to 4, then -3 to x, -3 to 4. Alright. So now that's going to be x times x, x squared, And x to positive 4 is going to be plus 4x. Negative 3x, negative 3x, of course, negative 3 times positive 4 is going to become negative 12. Use your calculator if you're having a hard time at this. And then you insert the last factor right here. So you're still gonna do it again, by the way. FOIL method still applies, but this time it's gonna be even longer. So this to this, this to this, this to this, this to this, third term over here, and then this term over there. Alright? So okay, x squared times x, that becomes x raised to 3. X squared times 2, that becomes 2x squared, plus 2x squared. Next is 4x times times x. So this becomes 4x squared. 4x, of course, 4x times 2, that becomes positive 8x. Positive 8. Okay, so next is 3x, negative 3x. So that becomes negative 3x squared, and it becomes negative 6x. The negative 6x goes on to the negative 12 right here. That makes negative 12x. And then lastly, if I can reach it, that becomes, okay, so negative 12 times positive 2 is negative 24. So now we're going to combine these together. So it's going to be still the same. X, f of x is equals to that. So, but this time, we're going to simply add all the like terms, like the ones with x squared together with the ones with the x. We're going to separate those into their separate thing. Alright, since we don't have a term that goes with x raised to 3, we're just going to leave it here because there's no like terms. So we're leaving that. Now we're adding these together. The x raised to 2. Remember, if we're adding exponents, we're only keeping them with the same value. So it's always going to stay as 2. So 2 plus 4 plus negative 3, that equates to 3. So positive or plus 3x squared. So as you can see, the squared is still retaining. Next we go with the x's. So that goes 8 plus negative 6 plus negative 12. That's going to be negative 10x. And since we only have one constant here, that's gonna stay negative 24. So that's our whole polynomial function, and we're going to list it over here as stated below. X to 3 plus 3x raised to 2 minus 10x minus 24. That's the polynomial function. We're going to list our factors, which, if I remember correctly, the factors are, yes, x negative 3 or x minus 3, x minus or x plus 4, x plus 2. Those are our factors. So this time it's different, since if you look at this, we have a degree of 3. Alright, since we have this now, the exponent is raised to 3, but the degree is 3, which means it's an odd degree. And the sign of the leading coefficient is still, of course, it's still positive. That's on a good note. Our zeros or our x-intercepts, you know how to get that. We're going to make use of the factors. So x minus 3, we're going to equate them to 0 if we're going to find the zeros. See, you know what? It makes sense. Alright. So plus 3 plus 3 minus 4 minus 4 minus 2 minus 2. Right here, minus 2. Right, okay. So x is equals to positive 3, x is equals to negative 4, and x is equals to negative 2. Those are our zeros. X is equals to 3, x is equals to negative 4, x is equals to negative 2. So our y-intercept is just going to be what's in the constant here. So that's negative 24. Y is equals to negative 24. Number of turning points is just the degree, which is 3 minus 1. That's equals to 2. That's how much we're going to turn. So now we're going to graph it. Since we have everything put up here, we're now going to graph this polynomial function. Okay, so we do know that our zeros are put here. So our x equals to 3, x is equals to negative 4, and negative 2. So we have our zeros put up, and our y-intercept is negative 24. So I can't write up to 24. So we're just gonna have to pretend that this is 24 right here. That's negative 24. Alright, so we have that wrote. So based on the behavior, we have an odd and positive. So odd and positive has a behavior of left downward and right upward. So from the leftmost, left downward, right upward. Alright. So now, this is going to be a tricky part. You would say that normally you would go here and here. But we don't know when we're going to turn in the right place. So we're going to solve for that. First, we go through the first line in the left, and we stop here. So in order to find when or what y-axis part we're going to turn in order to arrive in this area right here, as I've said before, we're going to solve for it on substitution. So based on our factors, we have x, or x minus 3, x plus 4, x plus 2. We're going to look at this part. From this and this, the parts or the points from these points. So we got negative 4 and negative 2. So what is the leftmost value out of or between these two right here? It's going to be negative 3. So we're going to make use of the substitution using our factors like I said before. So this becomes x. Instead of x, it becomes substitution negative 3, because this is the leftmost value between these 2 points. So negative 3 minus 3 and negative 3 plus 4 and then negative 3 plus 2. So make use of your calculator, because it's gonna be quite a bit hard thing. So negative 3, that becomes negative 6. Negative 3 plus 4, 1, and then negative 3 plus 2 is negative 1. Negative 6 times 1 is equates to negative 6. Negative 6 to negative 1 is simply positive 6. Alright. So now that we have that, I'm going to erase this. Wait. So our turning point is going to be at the y-intercept of 6. Right here. So now we know that going up until we reach the 6th turning point, because 1, it goes to 6 right here. 6. And go down once again. It lines up. Now, in order to find out this area, we're going to look between these 2 points right here. What is the rightmost value we have? It's positive 2. Alright, so since we have positive 2, I want to solve for that again. Positive 2, so 2 minus 3, 2 plus 4, 2 plus 2. So our value here is the rightmost thing is 2. Now, make use of your calculator here, if you're not easy, or you can just solve for it. Actually, don't need a calculator. Negative 1, 6, 4. Negative 1 times 6, negative 6. Negative 6 times 4 is equates to negative 24. As I've said before, this is negative 24. And there you go. Now you know. You go through it, you go through here again until you reach the top. And that's it. That's everything. So after that, after you got your graph, you move on to the next page, create your masterpiece using that same graph. You know, I don't know how you're gonna make this. Maybe a plateau. This is gonna be a mountain. You decide. It's gonna be forests. It's gonna be a sunrise. It depends on how you make your masterpiece using the graph situated right over here. And pretty much that's all for today's video. And hopefully I was able to guide you through this performance task. And so I really hope that you finish this as fast as possible or as soon as possible. And I'm gonna see you in the next one. And then next, we do x times negative 4. We get negative 4x. It depends on how you're going to approach this. But in the end, you know, it really doesn't matter. Okay, it doesn't matter.